It feels like Netflix knows you better than your best friend. You scroll through the app, and the perfect movie is just sitting there waiting for you, almost as if the system is reading your mind. But the algorithm has never watched a single movie. It has no idea what a plot twist is, and it has never felt a human emotion. Every time you rate a film or even just watch 80% of it before turning it off, Netflix quietly logs that action as a single, isolated number. Behind that slick interface sits a cold, massive spreadsheet of disconnected data points. This creates the primary engineering problem the machine has to solve. In math, this massive spreadsheet is called a matrix, mapping millions of users against tens of thousands of movies. Because no one has watched even 1% of the catalog, this grid is practically void of information. Almost all cells are completely empty. The system must figure out how to fill in millions of blank spaces, accurately guessing what you would rate a movie you haven't even seen yet. The primary hurdle is identifying a signal inside this massive void of missing information. To solve this empty matrix problem, engineers rely on a specific mathematical process called singular value decomposition, or SVD. Think of SVD like an industrial machine. It takes that messy grid and forcefully compresses it into smaller, highly concentrated blocks. It discards the noise and empty space, holding on to the most crucial patterns. What survives are hidden dimensions of human preference, neatly separated into user taste and movie DNA. These hidden dimensions represent distinct traits, like a preference for slow-burn sci-fi or a secret interest in bad horror movies. No engineer sat down and hand-labeled these categories. The math found them entirely on its own, purely by analyzing patterns in what people watch together. The financial value of this math was made clear in 2009. A team of researchers won a $1 million bounty from Netflix precisely by using matrix factorization techniques descended directly from SVD. SVD condenses millions of messy, subjective human opinions into a clean, machine-readable format. Once your taste is compressed, it becomes a vector. A vector is a list of numbers acting as coordinates, placing your preferences at a specific direction in space. Every movie gets its own specific vector too, describing the exact mix of themes it delivers. The recommendation process now functions as a geometry problem. The algorithm translates your behavior into a geometric coordinate, positioned in a multidimensional space. To decide if you'll like a movie, the system uses a calculation called a dot product to measure how closely your vector and the movie's vector align in space. This calculation checks the alignment of direction between the two shapes. A tighter angle means the vectors point in a similar direction, indicating that the movie shares your specific traits. As the angle between the two arrows shrinks, the percentage match score climbs. The calculation locks in instantly. This geometric comparison executes millions of times a second, allowing the system to rank the entire catalog for every individual user simultaneously. That match score dictates whether a movie lands in the top spot on your home screen or gets buried out of sight. A high percentage match is the result of two arrows pointing the exact same way. When you sit down on the couch and open your feed, all of this geometry is hidden behind a clean user interface. This matrix compression pipeline is the template for major recommendation layers across the web. Amazon uses this exact same vector math to map your shopping habits and predict which products you'll buy next. Spotify relies on identical coordinate math to surface new music that matches your taste. When a digital feed accurately predicts your taste, you're seeing the result of linear algebra, quietly doing its job.